and we are teaching them some algorithms like PID and RL. So let's get into it. So the main main motto of this is to do a line following. So there will be two sets of patches. One is with a black line with a white background and white with a black background. So they have to traverse from starting node to supply depot, and they have to pick the crates, and they have to switch the line, and they have to drop the crates according to the box which they have picked. And the learnings which they are getting is we are teaching them embedded systems, PID algorithm and RL algorithm, and some sensor integrations like color sensor and IR sensors, and making them to build bots. So these are some learnings which we are making them to do. And tools like us, we have in stage 1 we will be using the Copilia simulation software and Python for RL, and HTMCube MX is an GPIO configuring tool, and HTMCube IDE is something which will be using an alternative of Arduino IDE. So basically this theme is of STM32 based, and embedded C is basically we'll use to program the microcontroller. And this is our arena where I have mentioned that with the white line with black background and back line with a white background, this is the arena where they will be starting from the starting node, which is over here, and they will be traversing to the supply depot. This is a supply depot where the packages will be kept. They have to identify the color of the box, and they have to drop it accordingly to their respective drop zones. So this is the final configuration where the boxes will be kept. The red box will be kept here, and green over here, and then blue over here. They have to respectively drop those things in the blue and red and green drop zones. And as I have mentioned, this is the starting node, and this is the supply depot, and this is the dropping zones. And that this thing is the STM32 which we are using. The version is F103RB. And the 5 IR sensors which for line following, and then color sensor for identifying the package's color, and then a motor driver, and then NT motors, and an electromagnet to pick up the packages. And these are some board designs. Let's watch the theme film. And basically the scoring parameter has two things. One is the internal scorer, and one more thing is the judges scoring. So we'll look into the basic, like what is that, and basically PI, PP and PD are for package identification and detection and dropping it. And then PWS is basically the priority base. We have 3 packages which they have to pick in some priority which we have mentioned in the rule book. And bonus is basically without any penalty. If they complete, they will be getting that bonus mark. And penalty has 2 versions. One is if they drop the box in between or touch other boxes while picking other things, then the penalty will come in play. And then if they want to repush in the bots, then the penalty will be coming. So basically they will be having 2 repushes. If it goes more than 2 repushes, then the run is considered as an invalid run. And RP is basically if they skip some part of the line, then it will be included as a repeated penalty. And for the judging criteria, so judges can look into how they designed the bot and like how they kept the sensor placements. You can ask about it to identify the colors and control algorithms. Like basically this team have most of them here did both RL and PID in their tasks. So you can ask them regarding both of them. So and ask them how did they detect the packages and stuff. How did they make it closed loop, and you can ask about the picking and dropping mechanisms. And for the credit, so myself, Ajay, and then Shantanu and Ruchi ma'am are the team devs, and I would like to thank Jason, Arun, Madhu, and Shravan, Siddharth, and then inventory and the office team. And I would like to thank Ministry of Education for giving us the continuing the project, and we would like to thank Kavi sir as our founder, and then and our e-Yantra team, we would like to thank them. Yes, and at last our PI, I would like to thank Shivaram Kalyan Krishnan sir. So let's get into the team. We can start the run. So we'll start with 1881 team. You can come and start. Yes, sir. Scorers ready? Timers? Yes. Team, you ready? 1881. Yes, timer start. Package PI1. PI2 and then PP1, PD1. One manual intervention. Start from this one. Manual intervention 2. If okay, it's a invalid run, so just restart that. No, discard it. It's invalid run. Yes, hold on, team. Wait. Scorers ready? Timers. Okay. Start the run. PI1, PP1. Just move it back. Yes. Waiting. Hold on. 1 minute, team. Wait. Score is ready. Timer. Okay. Yes. Yes, it's a invalid run. You can. It's, I think there is some mistake there, but I can't do anything. No, your run ended. Just 2 runs. No, it's, you can. No time. Take them. You can go for the viva. Yes, other teams you can come and start the setup.
Hello. Okay. My name is Suvina Chakraborty and I am from DETC branch and we are from West Bengal. And named as Bishnupur sub-district.
My name is Obijit Sarkar. I am from Bishnupur.
As Shantanu.
My department is Electronics and Telecommunication, and my college is KG Engineering Institute in Bishnupur.
My name is Rupam Chakravarti. I am from Bisnupur. My trade is Electronics and Telecommunication Engineering, and my college is KG Engineering Institute.
My name is Soumik Das Koviraj. I am from Sonamukhi, Bankura. I am reading KG Engineering Institute from Electronics Engineering, Telecommunication.
Well, welcome all of you to IIT Bombay and to the e-Yantra event. Well done.
Thank you, sir.
Okay, it's great that you reached this and your bot was going quite fast. So, can you tell at a high level, like what was the approach you used? How did you program your bot? How did you build it also? Like,
While we're building, we have to keep in mind that what the position of the boxes should be and what is the dimension of the boxes. What will be the dimension of the bot and how it will
you
follow
can just hold it in your hand if you want. Oh, yeah, so this one, okay. Yeah.
While building the bot, we have to keep in mind the track, the boxes size and the dimension of the bot, and the solenoid, how far it will be from the bot and as well as from the track. And we have built a square shaped bot where solenoid is in the right side of the bot and IR is also in the right side, and TCS 3200 is also in the right side, and the IR array sensor is in the front that will follow the line in the track to move from starting point to the end point. And we have put the castor wheel in the front, and a little bit castor wheel jam has result in this error. If it is clean, then it will run smoother than as we'll assume.
I see. Okay, but then the controller, how did you get it to go like do the line following?
Okay, it's basically a PID implementation, and first of all, the knowledge that we get from e-Yantra has helped me to learn PID for the first time. And the study material that we get from e-Yantra is more than sufficient to learn how PID works and what is the role of KP, KI and KD and how to tune that. That was the main difficult that we faced in the whole journey from task 1 to task 6. And the main difficult we were faced in the transition from simulation to hardware implementation. We have faced many difficulty in the whole journey of our robot building, and every time when the bugs are coming and we are trying to solve or debug that, and we have sacrificed some of the sleepless nights for that, and even in the last bonus one we have worked around 40 to 42 hours out of 48 hours, and we have worked around 18 to 20 hours in the original configuration.
All right. No, that's fine. Good. So when you're doing PID, there is a notion of some state variable that you're trying to set to some value, right? So what is your state?
I can get it.
So PID means there is something you're trying to control, some parameter you're trying to control, right? So what is that in this case?
Okay, it is here we have to first we have to judge we have to recognize which state is the bot is in, and we have to do the debug by making the value of KP, KI and KD with the errors that were
exactly. So what is the error? The error is the difference between what two signals here?
The error is between the set zone, that is when the middle sensor will be in the white when the bot will be in the black background with the white line in the middle, then the set zone is 0. When the middle sensor or the IR3 will get the white and rest of them will get black. This is the set point, and after mainly binary weighted register are being weighted calculation has been done for that, giving us -2, -1, 0, and +1, +2. That will give the error. Means how left or right the bot is from the set zone.
All right, got it. Thanks.
So you talked about the role of KP, KI, and KD, right? So if you can explain how they sort of contribute to mitigating the error.
Okay, KP is mainly
Yeah. So what is the role of, let's say, proportional controller versus integral controller versus differential controller? How do they contribute?
Hello.
Yes.
Sir, proportional controller is zero. Is zero. It is 1. It is +1. It is -1. It is -2. It is
No,
+2.
like at a higher level, how do PID controllers work? So what is the role of a proportional controller to start with, and how is it different from integral controller, or how is it different from differential derivative controller?
I know, sir.
proportion is the how the error means more the error, more the KP will contribute to recover the error, and integral means KI. KI is mainly the sum of error from the past to the present, means previous error to present error, and KD is mainly the differentiate, the rate of change of error. If it is for example, if the previous error is less than the present error, yes, then the KD will be contribute more. And if the previous error is more than the current error, then KD will contribute less to recover that.
So do you, in this setup, do you care about the integral part of it?
Change this side.
Because at each step, you don't really care about, let's say, what happened in the past, right? Because if, let's say, you may have deviated slightly from your line initially, but now that you are looking at your current reference, you should, should you put more weightage on proportional and the derivative part?
I should, because integral will means for a very long time the error will sum up to a large error. And
But why do you care about what happened in the past, right?
then it can
It's
be-
not the fixed steady state that you are tracking, it's moving with time. Your reference is changing with time. Every time your reference is being defined with the current state of your bot, right? Okay.
So let's talk about the package detection algorithm you had. You said you're using infrared to detect packages, the boxes.
Mainly it is on TCS 3200. It is a device that has 64 photodiodes in the front area, and out of which there are 16 red detecting photodiode, 16 green detective photodiode, and 16 blue detective photodiode, and 16 colorless or no color. And with the configuration we are checking each time, means the configuration. The configuration are set by S2 and S3, keeping one at low, one at high. Will determine that what color we will detect. And for a reason, if we put the red color, and it will detect red, means red 16 photodiode will detect and send the means infrared, and it will capture. And the capture light intensity will be directly proportional to the to frequency, and it will decide how much frequency it is getting.
Okay.
Means the light intensity that will be captured by the 16 red photodiode will turn it to a frequency.
Okay,
And
understood.
next also same for green.
Got it, that's fine.
And
Thank you.
thank you, sir.
Thank you.
Thank you, sir.
No, this is team 2808 from St. Francis Institute of Technology. Yes. Scorers, you are ready? Wait. Timers ready? Yes. Team, you are ready? Yes. Once the bot starts moving, you can start the timer. Yes. Yes, team, you can start. PI 1. Reposition 1. Reposition 2. If it is one more, then it's a. Two. Reposition 2. Yes, invalid run. What's the issue?
Sir, I think the red box was a little far away from the electromagnet part, so was unable to pick up.
Just waiting. Wait. Waiting. Scorers ready? Timers. Yes. Yes, team. You can start. PI 1. Reposition 1. Reposition 2. It's invalid run. Yes, yes. You can go for it. What is the issue?
Help.
What is the issue? 3579 2410.
Good afternoon, sir. Good afternoon, sir. My name is Srihari Punna. I am from St. Francis Institute of Technology, Mumbai, currently in final year EXTC. These are my colleagues, Yash Dubey from EXTC and Vaishnavi Gaikwad from EXTC, final year. So we participated in crop robot. Unfortunately, it didn't complete the run. So, yes, sir.
Can you maybe hypothesize what happened? Why do you think it failed on both?
Sir, there are two reasons. In the first attempt, there is a priority to lift the box, first red, then blue, then green. So while picking up the red box, it was little far away from the electromagnet point that we have. So it could not means in its range of means attraction, it was not there. So it didn't pick up. And after that, the at the dashed line, it flipped back 180 degrees. So that run become invalid.
No, but were these things different between training and today? Like, is this something you're negotiating for the first time? You must have practiced on similar arenas with similar placements and so on, right?
Yes, sir. Maybe the lighting conditions was also be an issue, I think, because in our college, Matt, the lighting condition was different. Even today morning we were practicing outside, so there also we calibrated again, and it was also different. So it takes time to calibrate and tune the bot.
So in your practice runs, when we were doing it, it was doing it perfectly?
Yes, sir.
Okay.
Even in our hostel, night we practice it. That time also it was doing well.
Okay. Can you briefly describe both the design of this, why you made it in this particular way, and also your control algorithm? Briefly.
Yes, sir. So basically, this is a task-specific robot. Our theme was to deliver fresh farm produce in less time by detecting their color and stuff. So the crate is given on which the on above surface there is a metal piece which the electromagnet detects. So for this purpose we have made this arm. It is a 3D printed arm. It's a custom arm. We ourselves designed it in SolidWorks and then got it 3D printed. Then we assembled it at the chassis. That chassis is also custom made. It is designed in SolidWorks and then laser cutted. And then we assembled all those components. Batteries, sensors, microcontroller and stuff.
Okay. And what is the algorithm that you ran?
Sir, right now it is in PID and we were given two options. Earlier we used to simulate in PID and as well as in RL. But now if we chose RL this time, it was very slow, means it was not favorable. It will complete it will take very much time than PID. Because simulation and real scenario is very much different. So we implemented PID. Yeah, sir. So it took time to tune it, but now I don't know why it didn't run.
All right. Thank you.
So I see you have placed the, this is the color detectors.
Yes, sir. Color sensor.
Yeah. So you could have used this, like let's say it did not grab the red box, right? So you can still see the signals and you can use that and wait, like you could have designed or implemented the algorithm where it waits for this to continue to detect red for let's say 2 seconds before you start moving, right? So that's
Sir,
one way to
that
make
actually
sure.
we have experimented that. It was working without that delay also. Actually, we had a sequential arrangement of tasks earlier, but now we use free RTOs. So the PID was learning parallelly with the other tasks, means box
PID is
detection.
just for making sure that this stays on track.
Yes, sir.
But this is to ensure that you have actually picked up the object, right? Because if you had, let's say, in this case, it went there and it did not pick up the or grab the red box for you. But you can always use that signal to make sure that to ensure that the red box has been picked up, right? There's a signal for you to take that call.
So
and
actually, we have tried it, and out of in bonus task there were this is only a single set. In bonus task there were 3 sets, and in every set it was working. I don't know why, but now it doesn't work. So we actually don't require that. So we didn't put any delay and all. Actually, there is a delay, that 150 ms delay, but that was enough, and I don't think it failed.
So this is a good learning, right? So you should always design for failures and not for success.
But sir, we have to also check for the time.
No,
right?
I mean,
Shortest time.
if you're not able to complete the track, then time doesn't really matter, right? The other thing is, I saw that it struggled when, like, it saw the dashed line, and and also when it suddenly saw the big square on the way back, right? So why do you think that happened? How is your switching algorithm from white to black, or otherwise it's like how is that working?
Actually, the issue is because of the weighted sum, like when it basically leaves the line that is on the black surface, it basically follows the last error. So while since the dashed line is at the turning, so it always gets a negative error and it rotates that way. So what we have to do, what we actually did for it is maintain a very low KP. So we tried it and it was working, but not this time.
Okay.
Actually,
Fine.
the lighting conditions were.
Yeah, so that's another learning, right? So when you design, you make sure that it works under different lighting condition. Your threshold and otherwise should also take into account different lighting conditions. Thanks.
Thanks. One of the things you mentioned was for RL it was running very slowly. Can you explain why? I mean, you're not training while you're running, right?
Can you say? Sir, actually, we split the work. I worked for PID, and they like I have not worked with RS.
They can answer, that's fine.
Sir, so actually while we were simulating, RL requires time because after every attempt it learns and stores certain value for the line following, right? So initially we had to start the run at very slow speed. It was completing the run around, let's say, 5 minutes in the simulation environment. So later on we gradually increased the speed, and one queue table is there where the values are stored. And after every mistake, the reward system is there. After every mistake, it takes a negative reward, and accordingly it learns to not to repeat that mistake again in order to get some positive reward and maintain proper line following. But in actually means in a real time situation, the means the queue table is not means in simulation environment everything is ideal. Here some practical factors are also there which matters, like threshold of the means arena, lighting conditions, and our hardware, because the weights and means alignment, symmetry, all these things matter. So might be that could be an issue.
Okay, thank you.
Yeah, so in the context of reinforcement learning, there is states. So what is a state when you did reinforcement learning?
Sir, we had actually 6 states for forward, soft right, soft left, sharp right, sharp left.
Those are actions.
So actually the states were when the line was center, then second was state was the line was in a left corner, then right corner, right, left, and left, and the sixth state was the then the sixth state was the lost line. So whenever it whenever the sensor detects
6 possible positions of the line as you're sensing it right now. So you get the 5 sensors. Depending on that, you say it is this state or this state or this state.
Yeah.
You put it into 6 states. So your Q table has only 6 states. Okay. All right. Thanks.
Yes, team, you can go for the seminar hall 1 for the interview. Scorers, this is team 3579 from BMS College of Engineering. Yes, wait. Scorers, you are ready? Timers? Yes. Yes, team. You can start the run. One manual intervention. No. Done. No. 2 manual intervention. Yes, it's a invalid run. Shantanu. Go to scores. Yes, wait. Scorers, you are ready? Timers. Yes, team, you can start. Manual intervention 1. PI 1 and PB 1. PD 1. PI 2 and PB 2. PD 3, PD 2. PI 3 and PP 3. And PD 3. And PW is 270. And yes, end of the run. And there won't be bonus mark, and they add 1 penalty. Yes. Team, you can go for the viva.
Hello, myself Nandan. I'm from BMS College of Engineering. I'm from Electronics and Communication Engineering Department.
Hello, I'm Nirvara. I'm from EC Department, BMS College of Engineering.
Myself, Pavan Pai. I am from EC Department and BMS College of Engineering. So before we start, we would really like to thank our principal sir, our head of the department, and Girish sir for supporting us throughout the entire competition. So.
One more team member.
So one more team member, because of some personal reasons, he couldn't come. Rashmikas.
So yeah, good job, guys.
Thank you so much.
Yeah.
Thank you.
Yeah, can you elaborate on the control algorithm that you used?
So, sir, we used PID control algorithm, and so should I explain?
Yeah. So what is your reference,
logic.
or let's say what is the state that you are, or error that you are trying
Yes,
to
sir.
minimize?
So basically, what we did is first and the foremost, what we realized is the PID it works well in the straight line and in curves, but when it comes to 90-degree turns, then what happens is the bot, because of the speed of the bot is not able to react enough for it to take a turn. So what we did is we made the PID dynamic rather than keeping it constant. The constants of the PID are around 45 for P, D is kept around 10, 10 and a half, and integral is 0 because we don't want the error to be summed up. And sir, the main algorithm we used is for the base PWM for the motors, we kept it dynamic. It was not constant. What we did is, depending upon the error we are getting from the sensor, we reduce the PWM of the bot. For example, if the base PWM was 200, more is the error, lesser will be the speed of the bot, because of which the bot will be able to react enough. And one more thing we did is, for the weightage, for getting the error, there will be weightage of each of the sensors. So the center sensor is where ideally the track should be there. The center out of the 5 line array, the middle one. So if the extreme one sees, it would be -2, -1, and 0, 1, 2. And what we did is if 3 of the sensors, basically either the center 2 or the center left to or right to sees a value, then we increase the weightage, basically increasing the error so that the bot reacts much more aggressively. That was the entire logic we used.
So your errors are discrete states, or do you?
Yes, sir. It's basically it adjusts depending upon the sensor reading we are taking. If yeah.
The other sensors could be actually partial. So suppose say if the bot is at an angle, then what it does is basically the center sensor could see the half of the white line, and the left middle sensor could see half of the white line. So basically we prioritize by, as I said, we prioritize by putting weights on it, saying that if it's drifting to left, pull it back in, something like that.
And also I would like to mention about one more thing. As you mentioned about the 90-degree turn, since it's very fast, like sometimes it used to miss the 90-degree turn, it used to go straight. So what we did was we use a variable called as some error memory. What it did is, like, before losing the track, before all sensor sees complete black, it will see which is the last at last which IR sensor, which line sensor saw the white path. So it will store. So basically it will turn in to get back. Let's say now the 90 degrees like this. It went out like this. So obviously the leftmost sensor would have been seen the white before losing the track. So whichever sensor has seen the last, we made it to turn towards it so that it will again come to the track. That was one of the algorithm that we used, like basically the loss tracking algorithm that we used to, especially to overcome the sharp edges.
Okay, fine. Thanks.
So in the last drop, the green part, it had gone off and then quite a bit far off and then came back to the line, right? Yeah.
So sir, what happened is after the turn, once the box was ejected, we actually kept, it's basically once the box is ejected, and if it has not taken a 180-degree turn at the end node, then the box should forcefully turn by 180 degree. We aren't using any PID there. We are just forcefully turning the bot for some amount of time. So we made sure that there was an overshoot, because if there is an overshoot, then the bot will surely pull it back. But if there is an undershoot, then the bot will go out of the track. So we were on a safer side and we did that.
Okay.
And,
Somewhat general question, right? Compare your robot with you or me driving a car. What do you think is the main conceptual difference?
from what?
If any, right? In what way is your robot different from the way you and I will sense, drive a cycle or a car or something like that?
So first of all, I would say the reactivity, because the human perception time to some danger is much more less as compared to the bot, considering the much more high as compared to the bot. So I would say that's there. And
and one more thing, let's say especially the sharp edges or something, it will get to know only it reaches that point. But whereas if we are driving or something, like we will be able to detect it at little far distance, so we'll be able to take the reaction.
Right. So we are able to sense farther ahead before deciding what to do. So if you had to make like 1 or 2 small changes to make life much better for your bot, what would that be?
Sir, as you said, that was one of the biggest problems. The only eyes we had on the bot was the IR sensor. So we took a lot of time debugging it, because we didn't know if the first of all, so the IR sensor, the placement was a very big issue for us. Higher we place, more is the noise. Lower we place, the sensor, this part was like the white and black part was not getting detected. Yes, sir, 15 cross 15, and we wanted to save as much place as possible so that the edge doesn't go and hit the box.
Okay, good job. One thing you didn't say, BMS is Bangalore, right?
Yes, sir, Bangalore.
Good.
That's the first private engineering college in India. First private engineering college.
Established when?
1946.
Okay, this is one of the earliest public colleges started in India. Anyway, thanks.
Thank you so much, sir.
Team, you can go to speaker lounge for a interview.
Sure.
Okay. Here we have team 2410 from Sardar Vallabhai Patel Institute of Technology. Yes, team, you can. If you want to calibrate. Scorers, you are ready. Timer? Yes, once the bot starts moving, you can start the timer. One manual intervention. Two manual intervention and one penalty.
That position is correct.
Team, third run, team, it's third reposition. So invalid run. Scorers ready? Timers? Yes. Yes, team, you can start. Team, one manual intervention. Second manual intervention. Yes, it's done. It's a invalid run. What is it?
4 plus 6, right? Yeah.
I'm Raj Parmar. We are from first year Computer Science Engineering, SUIT. It's near Vadodara.
I'm Jimil Patel, and this is.
Good afternoon, I am Aditya Mathur, first year computer engineering undergraduate from SUIT.
I'm Savai Sudhar, first year studying computer engineering.
All right, so I would request audience to give a round of applause to this team. We're all first year students, okay? They started engineering not even a year back, right? And they've made their way all the way to the finals. So well done, congrats.
Thank you, sir.
You got a little unlucky today. So what happened? Like multiple times your robot tried, it sort of lost the line.
The electromagnet was way far, and sometimes the color sensor was also.
Little bit louder.
The electromagnet was kind of far from the box, and it was not quietly sticking to the box.
No, did something happen today which had not happened during your practice runs?
No, no, no.
It's the same thing, right?
Nah, in practice when we practiced, it was there was no error in picking off of box and sort of. In here we faced that.
So what did you face here which you did not face in the practice run?
Weak electromagnet, we can say.
But this is what you had earlier also, right? Did something change?
Position of box was way far. When the bot was turning, our PID makes the bot turn faster rather than going out of the line and then turning it. So the bot takes time to center itself. And the position we have given right now was directly just after the 90-degree turn. Hence, the bot was turning itself and box was placed there, due to which the box was kind of far to the electromagnet and the color sensor, which was inconsistent in detecting the color and turning on the magnet.
You seem to have an interesting design here, more like a 4-bar kind of mechanism.
Yes.
Any reason why you went with this specific design? Because a little bump and this will...
We choose this due to the variability of position.
Yeah, but like you can see that, right? Very easily you can, like, as you said, like it would, at least in this case, it should have helped you because you could have taken it close, like maybe farther away from the bot, and the issue that you seem to be describing, right? That wouldn't have been there.
I tried, but maybe it was not our luck today.
The other thing is, if you are having something like this, right, you need to make sure that it gets locked as well. Because if it doesn't get locked, what happens is that maybe one of the boxes bump into it, and all of a sudden the position of it changes and the strength and everything will come into play, right? So even if you want to make it variable, make sure that you are able to lock it in whatever position you want it to be. So do you think it was the electromagnet, or it couldn't even detect the package? How do you know it detected the package there?
There was LED indication. It blinked for a second, few milliseconds. Then hence why I found it that mostly the color was detected, red color was detected, but magnet was unable to pick up the box.
Okay. Okay. And what kind of control algorithm did you choose?
PID control.
Okay. And how did you define the error signal for you? Like what was the error signal on which you were running PID?
We have used weighted sensor where we see the line. First we normalize the line, calibrate it, and after we seeing the line, we have given a weighted distance for which if the bot assumes the bot is that much unit farther from the line. For example, we have given +3 and -3 for let's say if line is in the left hand side, hence the bot thinks that it is 3 units farther from -3 units farther from the line. Hence it gets a perceiveness of going to drift on left side to catch the line.
So why did you think it couldn't follow the line there?
On dash part?
Yeah.
There the main reason, we have been trying to fix that a lot, and many of the teams were also. The main reason is at the dash point, the first thing that happening is a 90-degree turn, for which we require a great KP. I mean, proportional term should be higher to turn that with that much strength. After that, the line is kind of very short, and black region comes. Hence, the bot thinks bot is running in milliseconds of delay. Hence, the bot thinks that just after turning, it has lost the line, due to which the error spikes up very high due to high KP, and that's why it just flips off.
Did it work in any of your trial runs?
Yeah, it was working.
It was? Or
it was working.
It was working.
It was working.
Okay. And what about the point where it was kind of going completely out, right? That was just because it was the error was spiking?
Where can you exactly specify?
So after it had turned, it was kind of turning back and coming back, right,
Yeah,
in between.
in the dash part, na?
Huh.
Yes,
This is the same
it was
thing?
due to the error.
Okay.
After it turns, it does not see the line, that, hence why it tries to move on the opposite end to get
Okay.
fetch
But
the,
it looked like it was actually following the path backwards afterwards. No?
due to, it was turning, but then after again getting the line, getting the
Okay.
sensor values, it was then following again the
Okay.
PID.
Fine. All right. Thank you.
Thank you, sir. Thank you, sir.
Team, you can go to speaker lounge for interview. This is team 4426 from Plaksha University. You want to calibrate? You want to? Yes. Scorers, you are ready? Yes. Timer. Yes. 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 Yes, team, you can start. PI1, manual intervention 1. Team, you need to keep it. Team, you need to keep it in the starting mode. Okay, it's a invalid run. We started. Waiting. Wait. Scorers, you are ready? Yes, team, you can start. PI1, RP1, reposition 1, reposition penalty 2, team, it's invalid run. You can go for the viva.
Greetings, judges. My name is Anhad, and we are from Plaksha University. I'd like to introduce my team members.
Hello, I'm Tanmay.
Hello, I'm Rohan, and I serve as a team lead.
Okay. Hi, I'm Anirudh.
Yeah, please talk about the design of your robot and also about what you think happened there.
I'll divide this into, I guess, two parts. In the hardware part, we designed a robot on, first we tried to design it using Fusion 3D, but then figured out that it was way too complicated. So all we did was we went on Inkscape and literally drilled out all the holes that you see over there and CNC cut it. On the software side, we tried an innovative approach that is modular. We made something called a mission planner. This mission planner executes low-level mission steps. So say a mission step is a PID line following or color detection or turns or blind turns. All of these are then sequenced together into one mission plan, and then that mission plan is executed by the bot step by step. Once each step has a stop condition that can be attached to it. That stop condition could be stop at a node, stop at a defined time, stop at anything. And once that stop condition of that step is completed, it moves to the next step in the mission planner array.
So maybe think of this entire mission planner approach as sort of Lego blocks. So like we divide all of our state steps into very fundamental functions. So like we can actually control how far we are going, when we are going, what is it actually detecting. And that allows us to do two things, which is first, it's easy to pinpoint what the error was in a certain case. And secondly, it's also easier for us to, like, since it's modular, you can reuse the code very easily. So I can just so let's say in task 5 we had 2 boxes and we had to pick up 2 boxes and drop 2. In task 6 we had 3. But all we had to do with this approach was to just add 3 lines of code because the logic was already written.
Okay. And what was the low-level logic for each of the mission steps? Was it all PID?
No. So one of the mission steps is move PID, of course, and then one mission step was hunting for the box. So that is what was executed as the first step in this mission plan.
So we broke down all functions into separate files. So one thing we did is we didn't really stick with the structure of the STM32 ID that we were given from the e-Yantra team. We actually went ahead and tried to make it more modular. So we created like 10, 15 header files or 15 files, one for the color sensor, so that we could tune everything individually. We didn't use a state machine, which is, I believe, what most people did with switch case statements. So what this allowed us to do is, in an optimal event, this would function perfectly. So we got one of the faster times in the stage 2, which is essentially the same run. And stage 2 was the hardware run, which is the exact same thing you see here today. So when optimized, it is a truly excellent architecture. Like, that is what we dedicated the most of our time to.
What happened with the detection today?
It was mostly PID issues. Sensors had to be changed. We were practicing right outside this arena, and we were able to get 3 labs working right outside the auditorium.
So I guess in the first run, what happened was the step move PID in that mission plan that did not complete, did not find its end condition of the inversion point. Basically, our PID values were not tuned properly for this mat. It was tuned for the mat outside. And in the second run, I believe what happened was, because of the mission planner approach, I could see what happened. The hunt mode did not end. So we had programmed the plan to hunt for the red box first because that had the highest priority. It could not reliably detect the red box. It only saw the blue box. And thus the mission could not exit. It did not find its stop condition and did not exit to the next line.
So given some amount of time for tuning in lighting conditions, I guess that would be one of our drawbacks, which is it does require some amount of tuning. Although we have in-loop normalization, so how our PID logic works is that it runs every 5 milliseconds. It takes the reading every 5 milliseconds, and then calculates the maximum and the minimum value and normalizes all sensor readings based on that. We believe that would be enough for the lighting, to solve the lighting issues, but clearly not. But the stop conditions that you see for the mission planner are fairly robust, because as long as that end condition is not triggered, for example, the red box being picked up, if the PID control was perfect, which it was not, it would have, you could literally keep it over and over again until it reached the inversion point. So it would not, like, once messed up, it would ideally figure out the next step on its own.
So your red box was never detected, is what you feel, or?
Yeah, the red box was never detected, so it never found its stop condition.
Why did it then continue moving on to the same track and towards the drop-off position?
So it was trying to find the red box.
Okay.
So So it's
Okay.
hunting for the red box, and it didn't find the red box, so it's still hunting for the red box.
Okay.
Found it again, yeah. Tried again.
Okay. So I see that the sensor placement here probably make the connections a bit tighter, because these are the potential issues for having different, like your thresholds may not work for, like may work for one setting, may not work for other settings.
Exactly,
because
yeah.
it's very easy to displace these sensors, right? So make sure that when you're designing boards, right, the main sensors, the eyes of the robot, they are firm in place, right? And it's the same issues with the other sensors as well. Like I see a lot of loose connections here that you should probably focus on, maybe on the hardware aspect of it.
Right. One of the things is like when we reached here, we saw that a lot of teams have used specific containers which were made for the IR sensor, and we were also thinking of using that approach. And one thing which we should have done and did not do is probably, so what happens is that on the black line on white background part, the white reflectance is very high. So it often, so the IR sensor often catches a gray thing even when it's on a black, and because the whites are so bright, whites are all 4095 values, and to stop that from happening, what you could have done is probably had a custom made array of 5 IR sensors and make all of them black, so like it's a container in a black format, so you only see the line.
Like this logic is also actually used in the, we were unable to demonstrate it obviously, but in the U-turns that are made at these end nodes. So it takes a U-turn and then checks whether the background, the white background, which is overwhelmingly white, has been detected again, and then stops the turn. So we figured that out, we figured it out for the turns, but then we did not carry it forward for the actual IR sensor.
Sure.
So just in summary, what were your most major challenges? Top 1, 2, 3, right? While working on this, what took you the most time? It was hard to figure it out.
Number one, most important would be the tuning parameters. We had to define specific KP, we did not use KI, KP, values for specific mats, which is why it was unable to be reproduced here. Second, I would probably say,
so one of the problems was adjusting the IR sensor. The thing is, our chassis broke off yesterday, and we had to, it was the last phase job, we had to fix the entire thing. And because of the heat here, one of the sensors actually melted. So I have to fix it with a hand.
The heat here is hot enough to melt
actually,
sensors?
yes.
Wow.
So like his
I think with repeated overuse combined with the IR sensor is actually the IR one is like
The-
really hanging over.
So maybe you should do something about global warming next. All right, anyway. Good attempt, so thank you guys.
Thank you so much, sir. Thank you so much.
This is, guys, you can go for the speaker lounge for the interview. And this is team 4217 from University of Knowledge Technology, Ongole. Scorer, you are ready? Yes. Yes, team, you want to calibrate? No, yes, you can start the run. PI1 and PP1. One manual intervention. Team, you start from start. Two RPs and then one more repo. So you want to end the node? Yes, it's an invalid run. You want to calibrate? Please calibrate. Chorus ready? Yes. Yes, team, you can start the run. PI1 and PP1. Manual intervention 1. Manual intervention 2. Yes, third one, it's an invalid run. No, it's not a valid run. At least one box. Yes, you want to calibrate it.
Good evening, everyone. Myself, Sonu Sathik. I am from third year ECE from RGKT Ongole campus, which is located in Andhra Pradesh.
Good evening, everyone. Myself, Lokesh. I am from third year ECE. I am from RGKT Ongole campus.
Good evening, everyone. My name is Samya and I am from RGKT Ongole, Andhra Pradesh.
Good evening to everyone. My name is Harshita. I am from RGKT Ongole, EC department.
Well, tough luck, but well done. You come to the finals. You ran into some bad luck, I guess. So it was failing at that same point multiple times. You understand why?
Yes, sir. Because of that calibration, sir. We have put some weights to the sensors. After that calibration, that weights the mismatch to the real calibration. In the test run, it works well, but here it failed calibration.
The test run was on the same arena.
Same.
So what has changed? What is here?
Lighting conditions, mainly the lighting conditions.
Okay. Okay. Can you briefly describe overview of the hardware, like how you built it, and also your control algorithm?
First, about the hardware built, we use 3D printing for the chassis. Mainly, you can see that we focused on the central gravity so that bot can move smoother on the curves and faster. The more you put weight on the upper side, the more the bot drifts, so that we have to maintain the height low. And then we use the PID algorithm, which is PD algorithm mainly. I is not used at all. PD algorithm same. We used proportional value to correct the error. We used mainly the low proportional value to maintain the bot smooth, and some D value to kept higher. Because we used more smoother moves, damping increases while increasing D.
Okay. So looks like everybody has used PID or PD or something. Did you do the reinforcement learning, maybe even in the simulation stage?
Yes, sir, we did. But I felt hard to tune that bot, sir, while training and that software simulation. It differs to the real world simulation mainly. We used the software simulation some values like floating values 2, 3 for the IR sensors. Here the IR values in simulation the IR values came up to 0 to 1. Here the values are 0 to 100. Mainly that is the main reason, and that reinforcement learning also we can't move the bot that faster more than PID.
Okay.
We have to train the bot multiple times, store Q table, and once the Q table is perfectly matched, we can increase the speed. But
okay, got it. So tell me one more thing. When you're tuning your PID, right, on the actual arena, let's say it was some value, you change the value. How do you decide whether you should go with the change or stick with the older value? What are you looking for? How do you evaluate the new controller?
First of all, we can response. First, we can watch the response of the bot. Either it is moving smoother or it is moving oscillating. Then we can decide which value is to change or how it turns on the sharp curves.
So qualitatively, you are assessing.
Yes.
Right. Okay.
Yes.
All right.
So on the RL part, have you thought of maybe tuning your, like use RL to tune your PI and PID gains? Instead of RL designing the entire controller for you, you still keep your PID controller, but use RL to come up with the right set of PID values for you, right? Or PD values.
We didn't use it RL at all.
Okay.
Only used PID.
And what was the error for you? Like how did you define the error?
First of all, the sensor, which have 5 sensors,
Mm-hmm.
it measures the distance between the line. The last sensor, this last sensor, and maintains the line distance. So it has some weights to each sensor, and it calibrates the
So is it a continuous value or a discrete value, like for your error?
We used analog methods alone.
No, as in the states, the error values are 0, -1, 1,
Yes, sir.
those
0,
kind of values, or
those kind of
you also
values.
consider in between values depending on your sensor readings?
Yes, sir. We use discrete values, 0,
Okay.
-1.
Okay. And I think so what was the role of this white thing that you have put in here?
It holds the sensors tightly to that chassis, sir.
So
whenever it,
at least on the hardware side, I see a lot of right things being done. You have made this a variable and thing. This is being made sturdy and other things. So that's a good job done. Yeah. Okay. Hard luck, guys.
So what is it you would change if you had, say, a couple of days more to work on it? What else could you try, knowing now what the lighting conditions will be? I know more calibration is always there. Is there something you can think of where you could calibrate faster across different lighting conditions?
Mainly the sensor, we have 5IR array. The fifth sensor is not working properly from before yesterday. That's the main reason it lots a line on that curve, tight curve. If sensor enters on that line and it moves inside rather than moving outside. That's the main reason for failing this run.
All right. Thank you.
Thank you.
Bad luck.
Yes, team, you can go to speaker lounge for the interview. Yes. And this is team 3486 from Yeshwantro Chavan College of Engineering. Yes. Done calibration? Yes, wait. Score is ready? Yes. Yes, team, you can start. PI1. PP1. PD1. PI2. Time stop, you can stop. It was a valid run. Why did you pick it?
Priority logic for box detection. So we use stack. First it will pick up.
It pick and paste one box, right?
Blue color and then grey color. But
no, it didn't mention like that. Yes, yes.
Actually, box detect पहले हो गया. Why did you guys pick it up?
अगर वापस वैसे हो तो run finish हो जाता.
Okay. Like don't interrupt, like let it complete the entire chase over here.
No, sir, it's a new run, second run. Yes. Wait, team. Is chorus ready? PI1. V placement penalty 1 and PP1. It's not a proper drop. Manual intervention 2. Yes, team, it's not a valid run. You can stop. Yes. No, team, that's all. No, that's all. You can go for the viva. Yes, you can go for it.
So my name is Sami Nawab. We are from Yashwantrao Chauhan College of Engineering, Nagpur. So in team, my role was to design the robot and joining the electronics and some logical part designing.
Good afternoon, judges. My name is Sumer Rizan from Computer Science Engineering. I am second year student. I am from Yashwantrao Chauhan College of Engineering, Nagpur.
Good afternoon, judges. I am Mohammed Shakib, team leader of this team, and I am from YCCE, Yashwantrao Chauhan College of Engineering, branch Information Technology, and we too did the software part.
So the first, the team member, he was out of the team from the start. So we forgot to mail the e-Yantra team.
So what do you think happened?
So the problem was like he thought that it was an invalid run or something like that, but it was going fine. The red, for the green box, it detected red because it was a little far away from the sensor. So it detected.
I thought it went to the spot, red spot itself, no?
No,
it
the
went to
green box
spot.
detected, the robot detected the green box red. So it's
So
as a red
how do you
color.
know that? No, but how do you know that it detected?
We saw it in there because it.
You had an LED to indicate
Yes,
which.
we have LED
Okay.
to indicate the box.
Okay, but you could have let it complete the thing.
No, sir. The problem was he thought that it was an invalid run, so he stopped it.
Okay.
Okay.
Fine.
That was a misunderstanding.
Okay, fine. And like RG and B are quite separated, right? So why do you think it would have like basically it would have seen red instead of green or otherwise?
So the.
So we have box detection function.
Uh-huh.
When the IR interrupt triggers, so it's triggers early. We are doing on the basis of interrupt. So what happened, like if we have battery have a high voltage, so it will detect early and it will stop early because we are providing PWM and it varies from voltage to voltage. So what actually happened there is like we have high battery voltage when the robot just detect the box green. So it suddenly stop. We have done like we have the delay like forward then stop for a second. But yeah. फ्रीक्वेंसी रेट इसलिए आई है कि लाइक वी कैलकुलेट द फ्रीक्वेंसी क्योंकि बॉट डिज़ाइन में ऐसे आईआर सेंसर पहले है राइट तो यहाँ बॉक्स इधर था ग्रीन तो यहाँ पे खाली फ्रीक्वेंसी आ रही है इस वजह से सबसे लो फ्रीक्वेंसी रेट की आती है तो इट विल ऑटोमेटिकली डिटेक्ट एंड सिंस वी हैव स्टैक लॉजिक लाइक First we push if stack of top equal to rate, then it pickups. So that's why that happened there.
This has happened before?
Yes.
Has it happened
Before in your trial runs?
Yeah, it's happened sometimes, but we try to fix it. But from yesterday, it hasn't happened.
Anything on the control algorithm? What kind of controller did you use? And
Yeah, we have used PID algorithm.
okay, and how was the error defined?
First, we calculate the weighted position. Then, after we identify how far right or left the bot is away from the center, we calculate then the PID. Like there is formula KP into error.
Sure, but again, are you using discrete values or continuous
Continuous
values?
values.
Continuous values.
Normalized values.
Okay, okay.
0
Fine.
to 100.
And your line following was doing fine in the first run. What happened in the second run? It looked like
There is junction condition actually. Like the start node is junction 0 and the supply depot. That node is junction 1. When junction 1 is detected, we set motor to turn 180. That's why when the robot follows, it detected is as a junction 1 and start goes into 180 state. So it's rotate.
Okay. Okay, thanks.
So at what point of time was your robot more or less ready? How much change has happened in the last 1 month, 1 week and 1 day?
Sir, our robot was ready after the task 6. It was perfectly fine. It was performing the same task within 1 minute 14 seconds and with very minimum errors and all that stuff.
When was that?
It was task 6.
Yeah, but February first week, 1 month back, more than a month back. Okay.
So after that, we have changed the bot's design because the design, it was limiting us from picking some boxes because the bots, that arm that picking the electromagnet was behind, a little bit behind. So it was not picking some boxes. So we have to change the design. And before our design was made from PVC, that in which the wire is sealed, PVC sealing wire. So we thought that we should 3D print it, and we took some 7 days to design the bot and recalibrated it.
This is after stage 6.
Yes, stage 6.
So about a month and a half back, you have redesigned the hardware.
Yes.
So then you had to retune everything after you did that.
Yes.
Design actually helps us, like far away box pickup you have.
So
I
the
Some kind of filter.
Yes, filter.
Okay. And how much after you came here, you saw other teams? Did you make some anxious changes to your code?
No, sir, we
No?
didn't change any.
We just fixed minor bugs like lighting conditions. Most commonly cases thresholds fail. Like there are two maps. So in one map we set the thresholds. It is perfectly working there. When we shift to another map, there we get different threshold. Sometimes it works there or not. That is the problem.
So let me ask you a general question. In the US now there are self-driving cars, right, which are clearly navigating much more complex, varying environments compared to this, right? How do you think they are doing it? What is the technology? Is it sensing? Is it the control? Is it something else?
There are maybe a lot of technology involved, like object detection, sensors, and computer vision is object detection.
So
and
if you had a
radar
camera
system.
instead of this IR,
Yeah.
you would have been able to do this, you think?
Now radar system also helps. So this collaborative help the machine to autonomously follow the roads or line.
Sir, also the computing power of that cars is very high because they are using LiDAR and calculating all the calculations in
That's
milliseconds.
true. So what minimal change to this? Suppose I gave you extra 2,000 rupees, 5,000 rupees, let's say some small number, and said you buy a little bit more, change your software, make this work. If you wanted to make it very reliable, what would you invest in?
So we will invest in we will regulate the battery voltage. So our right now, if the battery voltage shifted by 0.2 volts or something, the bot behaves uncertainly. So we can add some, the bot already has encoders for speed calculation. If we used speeds rather than PWMs by doing some equations, that would be much better for turns and all that. Because for that dashed line turn, we have to turn 90 degrees, then cross the dash lines. So if we set the manual 90 turns, we are not using PID 90 turns because it was not taking PID 90 turns in high speeds. So we did manual turns. And for that, we have conditions of timers, like 340 milliseconds to complete the right 90 turns. So instead of that timers, we could have used motion sensors or gyroscopes for detecting the orientation of the box for better maneuvering.
All right.
Sir, I have different.
Yeah,
His
yeah.
perspective also good, but I will apply computer vision. Like I am doing in minor in AI/ML. What I will do, I will train the robot. Means I will at the front of robot I will attach camera, something like that. I will train multiple times. It will record the value and based on statistics and probability, I will apply. So this will help the robot to successfully follow the line.
Good. Okay. Well done.
Thank you, sir.
Thank you, sir.
So, hello. So, under honorary conditions, we have invited some good performing all girls team. So, the names won't be there. So, you can judge them. 1 minute. Yes.
Detected the green box as the red box because of the distance of the color sensor from there, and because of the sequences, it is now looking for the green box, right? So it won't pick up the red box if I keep it there. So if suppose I keep the green box in this position, then it will go ahead and pick that up. Position here. Again, it's a detection problem. It did not detect correctly. I mean, that's the primary issue here. It will correct. It will complete the run accordingly. Can I? So.
Yes, you can go for the viva.
So I'm Swaliha Attar. So I'm Swaliha Attar from TY CE department from Cummins College of Engineering.
I'm Richa Ghomre from ENTC.
I'm Pratna Cholke and I'm from Computer Engineering branch.
I'm Ashwini Kadam from ENTC branch.
So that was almost okay run, I would say.
Yeah. Except
for the color
detection
detection.
part, yeah.
So did you observe this in your trial runs as well?
Actually, we were kind of happy for the configuration because this configuration, this particular configuration, especially for the red and green one, we had tried it for multiple times and it does run on this board. But unfortunately, it did not right
So
now.
does the logic get triggered the moment it detects one of the colors, let's say, or do you wait for like 3 or 4 continuous readings for it to stabilize before you say that it's a red or a green box?
Yeah, no, we did do that. I mean, that's a very good sanity check, I would say. But we did not implement that here since the time of the run was also important. We did introduce a 500-second millisecond delay for the for ensuring that the box was picked, but we did not do a second check as you were suggesting.
And once a box gets picked, like, do you continue to detect that the box has been picked, or you just placed a delay for now? Like,
Yeah, initially we had the function of the IR sensor. If you could see, the IR sensor is placed below the board. So the function of the IR sensor, what we had planned to do was, if the box is picked, then the IR sensor was supposed to go low, so that we understand that the box is picked and then the bot can move ahead. But the electromagnet and the height of the boxes that were given to us, they were so constrained and like the space was very limited. Even if the box was picked, the IR sensor could not really, did not go low even after the box was picked.
okay, thanks.
So I could see that the final box, it was refusing to pick up. Any idea why? It was
No.
still looking for a green box there, right?
Yeah, it was looking for the green box. What happened there was it was detecting the green as red again. That was the problem. If you could see, there was a minor red blink on the LED. It's just
Okay.
to say. Yeah.
And what about your control algorithm? What are you using?
So as all of the teams, we had implemented both RL and PID. In fact, in the task 4, it was mandatory for us to implement RL and PID, both of them, in 4A and 4B. But when it came to fifth task, we decided that we want to try both of them equally well. So in the fifth A task, we again went back to RL, tried to improve its speed and improve its accuracy before we jump back to PID, because we had done 4C in PID again because it was giving good accuracy. But again, we did 5A in RL, but it did, as compared to PID, the speed increment was not really as successful. So we switched back to PID again after 5A.
Okay, sorry, I missed, but which college are you from?
Cummins College of
Pune?
Yeah.
Okay, all right. So I don't know if it's my imagination, but it seemed to me that your controller was much more, you could say, slow and steady compared to the ones we saw earlier.
Yeah.
It felt like the previous ones were optimized for speed and they made mistakes in the process. Were you deliberately keeping it a little bit slower so that it would not miss the line?
Yes, that was definitely deliberate. What we observed was, if you would have seen, initially I took like 1 second calibration for the bot. So and in comparison to the other teams that faced issues because of the lightning conditions, right? So our robot had dynamic calibration. Like at the start of the run, I did a 1 second calibration where all of the sensors went high and low once. So the range of the values was defined based on the lightning conditions. And so based on that, we gave priority to precision, because if you could see the points, even if I would have completed the run like 30 seconds earlier, then to like picking and dropping the boxes had way more points than that.
Yeah.
So we did give more priority to precision over speed.
I think that's a good call. Frankly, I think qualitatively it looks a bit different. I feel real life implementation should certainly place more emphasis on, I don't know, slow and steady, right?
Yeah.
Rather than mad speed. So well done.
Yes, thank you, sir.
Yes, team, you can go for the group interview. And one more team, you can. fine. Yes. Might.
Is there one more team?
One more team. I think they know.
Good evening, sir. We are a all-girls team from Jawaharlal Nehru Technological University, Hyderabad. I'm Jyotsna, and in the stage one, as we are from the software background, it all went smoothly. And when we shifted to the stage two, the hardest part in this was not coding logic, it was just the environment, and the lighting conditions affected very much. Even the tuning was also perfect. There are days where there are no coding flaws, and tuning has done very effectively, but in one run it is going efficiently, and the other run it is not able to catch the line. And
so our run was not successful because of the sensor readings. As you can see, we did something so that the height of the sensor is increased. First, we tried to do it with the original area. We put it really down. At home, it worked really well. But then when we came here, the white background or black line on black white background was really difficult for the sensor to take it in. So we decided to increase the height of the sensor, but it didn't really work that much. We also tried to include that in the code. We calibrated it and decreased the threshold and did something, but at the end it didn't work out. And also for us, the difficult part was right turns. Our bot was able to take left turns very well, but then the right turns was really difficult, and that's why it missed most of the turns in that. Pickup and drop were nice. The only thing was there. Sorry. I'm Nishita, second year BTech student, cyber security.
I'm Indu Sastra, second year computer science engineering department from JNTU, Hyderabad.
I'm Chaitanya. I'm pursuing BTech first year CSC AML in JNTUH.
All right, good. So thanks. So you've had to work on integrating many different technologies, sensors, hardware, right? In parallel with that, work on the controller and so on. How much of this have you had to learn for the first time? You picked this up because of the competition, or did you already have some knowledge, right, to get started with?
First of all, we didn't know what it is, what eYantra is about. We just saw one poster in our college, and we decided why not take this. So we registered, and then got to know that it is a robotic competition, and which is in the agriculture theme. So we went deeper, and when we switched to the hardware part, the documentation was well enough to understand. But again, additionally, we went through the YouTube tutorials to learn much better than the documentation, and that really helped for us to continue.
Did you also use PID?
Yeah, from the beginning we continued with the PIDs.
So at first we didn't really know about robotics. At every step we learned something about it. So first was software implementation. We knew coding and we were able to do it, and tuning was the only thing that used in copilism and stuff. So we did that and passed into stage 2. It was hardware. At first we did got a lot of hardware issues, testing and stuff, but then later we overcome and we were able to do the whole this thing in under 1 minute or something. But then after that task 6 and all, our components try to give different outputs. Like what we expected was not coming from that bot, and so we did face a lot of hard things there, but at the end we completed it. And now I don't know why that happened because of that issues, but we tried our best to do it, and we learned a lot of things like using a microcontroller and PWMs and stuff.
All right.
So you said you picked it up because it was part of the agriculture theme. Any particular reason? Like, do any of you have family backgrounds or anything in the area?
We do agriculture, sir, in our hometown, so it made more interest to do this project.
Okay, good.
We were interested about the robotics part of it, and once the agriculture came in, she was like really interested that she wanted to do it. And
You are
so
the only first year.
Yes.
Okay, good. I think. Thank you. Bad luck.
And we have one more team. They are diploma second year from Government Polytechnic College, Nagpur. So you can start there. Yes. There will be one time to do. What should I do? Okay, then. Think. Team, you want to enter? You can go for the other. Yes. Yes.
Good afternoon, everyone. My name is Shweta Munkar, and we are from Government Polytechnic, Nagpur. We are the student of Computer Science and second year.
And my name is Pawar Shupra, and I am also from Government Polytechnic, Nagpur, and we all are second year students.
Good afternoon, sir. My name is Vaibhavi Vaidya.
So yeah, I see the first thing that I see is that the sensors have been placed way above the caster wheel, right? So do you think that's
Yes, sir. The sensor's alignment is too much high because when the sensor is on the below side, it not give the proper reading to us. It gives just a maximum value. So the difference between the black and white reading is not good proper. That's why the board not perform the well. But then we slightly increase the height and then saw the reading and variation. Then we just put the sensor.
also, did it break while you were during your trial runs? It looks like you have a lot of after thoughts on fixing this.
Yeah, sir, fixing is not good, but it worked properly. I think it's just alignment problem. That's why not that time it not speak up.
And did you use RL or PID?
We both work on both, but this time we use PID.
PID, okay.
So Polytechnic means this is your +2, like after 10th, this is your second year?
After 10th, sir.
So you might be the youngest participants then.
Yes, sir.
Right? Another round of applause. Very nice. So what prompted you to enter this competition and to take up this theme?
Sir, we just want to try some extra activities other than curriculum, so that's we participate in that. But we teach a lot from eYantra, and we get much knowledge from this. Cause we just heard the word microcontroller, but when we participated in eYantra, we get chance to handle how to control, how to use microcontroller and all things, sir.
So in your practice runs, you were able to finish the circuit?
Yes, sir. In all tasks, we perform all the algorithms and perform for completely all tasks performed.
And sir, as we just practicing that time, also our bot was working good, but I think there is a calibration changes. That's why our bot is performing. We will not perform.
There is environment changes, that's why the calibration is not performed good, and the pickup logic is not performing because the electromagnet, while we are traveling, the design was get some mismatch there is.
Anyway, I think it's a very creditable performance. So congratulations.
So did you ever find out why you were getting very high readings from the sensors? Because I think the other teams were not having this issue. So maybe you could even talk to them. And
Sir, I think our IR1 and IR2 gives constant value like 4095, and other sensors are showing variations. So when we increase the distance from then surface, then it will work and give reading properly. That's why we think that's better.
okay. Thank you.
Thanks.
Well done.
I would like to call Shivram sir to give the gift hampers to the judges. Sir, mine. Sir, Mayank Banner, you can come and get the gift hampers. And you can share the experience of this team. Okay.
So great job, everyone. So one thing that I was looking for, and first of all, I think for most of you, this has been a first sort of attempt at robotics and being like getting sort of educated about microcontrollers and also different control algorithms. And I think everyone chose to work with the PID, which is fine. I mean, in fact, this is a simple enough problem, and PID should be the way to go. People who tried RL, maybe they could have also tried tuning their PID using RL instead of trying RL altogether to control. But one of the things that I was looking for was maybe also look at velocity control and not just the position control or the orientation control. So many of you saw that at 90-degree turns or the zigzaggy paths where the line following was one of the major challenges. I think one of the teams that actually eventually got it right, they had manual sort of weight, like they had manually defined the weight, designed the weight so that eventually around those turns it can follow those paths, right? But if you look at velocity control, because you already had access to encoders, you could have computed the velocity, and if you had applied that velocity control around the turns, you would have been able to do a smooth job as well. But nonetheless, a very good attempt from everyone, and I hope maybe you learn a lot from this. Especially, I think every team pointed out that there was some calibration issue, and this is the real, like, this is what happens when you test something in simulation versus you get into the real world. Things will be different, and you have to design for failure modes as well and not just for successes. So good luck, everyone, and thanks. Yeah.
And I would like to call Harshad Har.
Good afternoon, everybody. Again, I would reiterate that everybody did very well. I don't want anybody to feel discouraged if their bot did not work. You know, this is usually what happens in your first attempt, and going from theory to practice is always hard. But I think I hope what this competition has inspired you to do is in your education and eventually when you go into work, even if you're not doing something directly applied, even if you stay in academia and teach, you think about how whatever you're doing would apply in the real world, you try it out, not just in simulation, but as experiments in real world systems. And if you can make actual products out of them, even better. Thank you.
Okay, that marks the end of this. And so we'll meet again at 5 o'clock for the Krishi Balancer theme. At 4:30, the snacks will be started to serve at second floor. So make sure you are back to the auditorium by 5. Thank you.